Hi, I'm Eric from Advantech. This short video has been made with the goal of offering you further insight into application performance, enabled with hardware acceleration using Intel's second generation Xeon processors and Intel Quick Assist technology on Advantech Sky 8101D server. This diagram offers an overview of the foundation used for the benchmark demo. Intel Select solutions for NFVI align with ETSI's NFV reference architecture and encompass the NFV tuned hardware platform and NFV software as shown in the block diagram. For the benchmark demo in this video, the server is an Advantech Sky 8101D. Intel Select solutions for NFVI do not specify the NFV management and orchestration or the VNFs, but are developed with a goal of being able to support an ecosystem of VNF and management options. The Sky 8101D verified select solutions for NFVI focuses first and foremost on delivering an optimized-based platform to provide a level of performance tested and verified with industry-leading KPIs. We then ensure that the settings recipe for BIOS, firmware drivers and various OS options is clearly articulated in the order to deliver on the performance promise that is verified through extensive regression testing and that it is continuously refreshed to integrate the latest tested and tuned software and drivers. Intel Select is an ideal foundation for any communication service provider wanting to efficiently deploy a modernized and transformed 5G ready network. In this demonstration video, we will present real application performance enabled with hardware acceleration using second generation Intel Xeon processors and Intel Quick Assist technology. The test setup is based on the Advantech Sky 8101D and NFV ready server with NUMA balanced Gen 3 PCI Express by 16 slots equipped with two second generation Intel Xeon Gold processors. The server is verified Intel Select solution for NFVI version 2 and certified with Red Hat Enterprise Linux and Red Hat OpenStack. The solution is available and shipping today. Here is an overview of the system configuration. A Spirent packet generator is configured to generate and receive traffic over the two Advantech PCIe 2320 dual 40GB Ethernet adapters. Traffic on the ingress port of the first adapter is encrypted by Fortinet's FortiGate VNF running on CPU 0. Encryption is performed in the first instance using Quick Assist hardware acceleration engines in the chipset, and in a second instance without accelerating using CPU cores for software encryption. Encrypted traffic is transmitted via the second port on the same adapter and received on the first port of the second 40GB adapter. The encrypted traffic is decrypted by a second Fortinet FortiGate VNF running on CPU 0. Decryption is performed in first instance using Quick Assist hardware acceleration engines in the chipset and a second instance without acceleration, using CPU cores of the software decryption. Now let's take a look at the demo itself. For the test setup, we're using Red Hat 7.6 and two virtual instances of Fortinet's FortiGate software. We have built an IPsec tunnel between the two virtual instances over the Intel XL710 40 gigabits Ethernet controller that is exposed via SROV. The tunnel is set up with AES 256 encryption. Okay, so now we are enabling the tunnel between the two instances. We're bringing it up. It's called Berlin Demo. You can see on the dashboard the CPU usage and also the throughput. Now each virtual instances has 3 QAT engines. These are also delivered via SRIOV, as you can see here. We'll be using a Spirent packet generator to drive traffic through the two instances over the tunnel. We will top out at about 5.6 gigabits per second, and you can see here on the right bottom the counters go up under the QAT section, demonstrating that the encryption and integrity is all done via QAT. And also on the dashboard you'll see that the CPU consumption now is at an 100% level for a number of cores. The network interfaces are handled on 3 and 4, and core 2 is handling all the QAT interrupt handling. So here we are. So that's 5.6 using QAT. Now we have to bring down the tunnel when we make the change, and we want to turn off the IPsec QAT offloading. Fortinet has this easy feature for that. They allow you to turn it off by a single command, so we'll do that now by turning off the IPsec QAT offload here, by disabling it. And then we'll run the test again. Now, of course, we'll downgrade the throughput that, or at least the traffic that the Spirent will be sending to the test setup, as we want to reach the maximum. We know that the maximum will be at about 1.6 gigabits per second total throughput. So we brought back the tunnel again. We prepared the test center from Spirent. We will now start the test, and you'll see that actually the throughput is about 1.55, 1.6. The packets are now, all the encryption is done, as you can see on the right bottom side, via the software, not the QAT. And also from core count, there's no QAT enabled, therefore core 2 is not being used, and all the traffic is handled only by core 3 and core 4. Let's review one more time the results of the benchmark. As demonstrated, the Fortinet FortiGate virtual next generation firewall was able to achieve up to 3.5 times higher IPsec throughput using quick assist acceleration on an Intel 6230N CPU versus an Intel 6230N without quick assist acceleration. This also results in an extra 10% more headroom available for VNF processing by the CPU. Thanks for watching, and for more information visit Advantech at www.advantech.com/nc.